Hello everyone, welcome back to my channel. Today let's go over a medium question that I just solved on my own after a lot of trial and error. And so let's go over it. Be kind of surprised that I solved this because I was struggling with it for a long time, but I guess just the whole idea that I'm going to show you popped up. And again, let me just show you how I did it. So you're given two integers arrays, and basically you want to figure out for each squared value how many pairs are going to be equal to that squared value. So for example, 7 squared is 49. How many pairs are equal to 49? So basically what we're going to do is use two hash maps to pre-compute the frequencies. So let's call this first dictionary, and let's go through nums of 1. So fd of n, you want to pre-compute the squared values plus equal to 1, because we don't care about the indexes if they're less than or equal to the loop in the other array, I guess. So if you're doing 1, then it's 2. If it's 2, then 1. So then sd of n squared plus equal to 1. So now we have a dictionary with 49 and then 16, both appearing once. So now when we loop through nums of 2, we'll just do a double loop through nums of 2, right? For j in range I plus 1, length of nums of 2. And now we can just say if the product is nums of 2 of I times nums of 2 of j, and then our answer is going to be an integer, right? So we're just going to add fd of product, because product keeps track of nums of 1. If this multiplication pair is equal to anything in nums of 1 squared, then however many times that appears, so if the 7 appears twice, and let's say this square times, or this times this is equal to 49, it's not, but then you would just add 2, because that's 2 pairs that you can make. If this was also 7, then this is another pair you can make. So that's how pre-computing the frequencies work. And then we can do the same thing for nums 1, right? J in range I plus 1, length of nums 1, and the product is nums 1 of I times nums 1 of j. And then we're going to do this in the second dictionary because we're on 1, sd of prod, and then at the end we can just return answer. So this avoids having to do n cubed because you're pre-computing the frequencies. And that's what I used to do, but then I did this, and this is passing all the test cases. So again, I'm pretty happy about this, that I was able to solve this on my own. And yeah, that's it for this video. If you're familiar with 2-sum or 3-sum, this is like a similar idea, but that's all I wanted to mention. So that's it, and thank you for watching, and stay tuned for more.